friends, my name is Shubham Chaudhary. I am with another project with you. It's a fake news classifier using LSTM. And what we do in this project, we have a data set which is taken out from Kaggle, and we have a large data set. It is around 20,000, and we find out what if the news is present in the data set, it is fake or it is true based on the label. If it is true, it is represented by 0, and 1 is classified, 1 news is fake. So in real world scenario, fake news is spread is like a fire. So how to identify it is correct or not? So we use various type of machine learning algorithm or a deep learning algorithm for the analysis of a fake news. And here we use the LSTM model for analysis of a fake news classifier. So let's start. Okay, what we do first, we first import the library of pandas as a PD, and then we import a NLTK library. It is a NLTK library. It is generally it is just like a NLP, natural language processing library. And what we do in it is it is generally used for sentiment analysis of word, or we can sentiment analysis of our sentences. It is generally used this type of a library, and there are various type of a function we are performed with this use with the use of this type of a library, like stemming, lemmatization, and stop words, also a function of NLTK in it. Okay. Okay, then we go out the next step. We just uh, taken out the data from my D library. It is a fake news classifier data set, and we have a train.csv. And here, this is our data set, and it is, I think, 5 columns and 5 features, or around it is 20K data. We have 20K row are present in this data set, and uh, 5 column is represented as a ID, title, author, and text, and a label. And title is just like a title of a news, and text, what is the present in the title, uh, it is okay, and label, it is represented as a our output, it is a fake, it is identify it is fake or it is true. And author, which is written by the text, which is written by the text or a title. Okay, so next step, what we just check the shape of our data set. It is around 20K, and we have a 5 feature or a columns, and then we find out the if it is a null value is present in our data set. So what we do, just check the null value and taken out the sum of all the null value it is present in our data set. In so ID has 0 null value, and title has mm, around 558 null values, and author is just like 1957, and test 39 null values, and label is 0. Okay, so what we do, just we drop all the null values in this data set, and then after that we check the shape of our data set is just reduced because we drop all the null values, and now our shape is around uh, 18,285, and columns are same, it's just like 5. And first we have a data set with the 20,800, and now when we drop the null values, our data set is our data set rows are around 18,285. Okay, just we now we separate the data for training and a testing data. Sorry, training and a testing analysis. So X is defined by data dot I log is 0, and to column 4 means that it is represented as a 0 form ID, and 4 means last is text. So it is data is only taken from ID2 and text, and it is extracted the label. Okay, label is placed in a Y because it is our dependent variable, or we can say it is our output. So now X is represented as ID, title, author, and text. Okay, and Y is our data or uh, label, and Y dot shape is around same. Okay, now we import the library of TensorFlow and TensorFlow as a TF, and from TensorFlow we have a inbuilt library such as the Keras, which are uses for various type function we perform in the TensorFlow, such as a padding sequence and one hot representation, word to vec or back of word bob, and various types of functions are performed with the help of a Keras library. So what we do in it, we just import all the important library for the analysis of a data set, such as embedded and pre-processing sequence as the padding sequence we use. Uh, it is generally used for uh, um, we can say that maintain the uh, same length of sentences. Means that convert each sentence into a same length of a data set. Okay. Now we use a sequential. It is used for creating a model. Okay. And next we have a one hot representation library we use. It is generally used for, we have a data set and it is converted into a vector form. So for converting the vector, we use uh, uh, one hot representation library, and then we import the dense function, dense library, and then we use the LSTM model for analysis of a model. Okay. Now we taken out the work size. It means work level size we taken out for equals to 5,000 because uh, we convert the our test data set into a one hot representation. So we need a library, or we need a vocabulary size. Okay, so what we do, just we taken out the work size is equal to 5,000. What, and next step is we just copy the x data, because we have a lot of a value in a, sorry, we have a lot of a null value present in our data set. So what we do, we just reset the index of the data set, and then it is placed in a message. Okay, now we import the library as a identity. Okay, import, it is a regression library. Okay, it is perform various type of a function. With the help of this, we perform various type of a function, such as we use for substitute for a word or separation of a word. Uh, we use many type of, there are many type functions are present in this library, and then we use a stop word, such as stop words are just like is, the, and these words are not uh, not so important for analysis because it is a less importance in the data set. There are no meaning. Okay, so we just import the stop words, and then what we just stemming the uh, sentences. After that, what we do, we import the library of stemming, water stemmer, for perform the function of stemming. We use a water stemmer. Here we also use a lemmatization. Lemmatization is generally convert the each word of our data set which is present in a text, convert into a meaningful or we can say the inner root word. Okay, so what is the we just taken out the empty list here, and now we use a loop for the I in a range from 0 to length of a message. Length of a message is around 18,000. So it is started with 0 and going to 18,000 round. And what we use, we just here we use a regression function, and it is a dot sub is means substitute, means that all the mark or a punctuation or other types of, means that other type of a mark is present in a text data are replaced with the spaces only, except the A to Z and capital A to Z. Okay, so all the empty spaces, or we can say braces, or punctuation mark, which is present in our data set, are removed it with the help of our regression library. And then what we do, we convert all the data set into a lower form, because Python is a case sensitive language. So first we convert all the data set into a lower format, because if we don't do this, same words become a different words for the analysis. So we convert it to a lower, and then we split the data set from each other, and then what we use for splitting, and then what we do, whatever is present in a REV object is passes through a word. If word in if word is not in a stop word list. Okay, stop word list means that it is a type of a library, which here sorry, it is not a library, it is a just like a list. In list is present is like is the, of, and their type of words are present in this list. If this type of words are present in our data set, just ignore it or remove it. Okay, only what then what only words are passes. So what we do, word are convert into a stemming, and ts.stem we use a library Potter stemmer, and then convert into a word is a stemmer. So we join all the words into a sentence with the spaces, and then that sentence is append into a app, our corpus, or corpus list, or a empty list. Okay, now after that we get a list, like just wait, I show you. I add take C O R P U S, and what is the 0. Okay, and enter. So corpus means that here we show that it is the first sentence of the text are present here. So house, dam, add, even, see, coming, letter means that is a house in converted to a house. Okay, so it is converted to a stemming word, and it is maybe another add, even, see, coming, letter, JSON. Okay, so it is another word, and we check out the uh, first word. What is that? So it is plain. Yeah, it is a Larry Clinton is conveyed Hillary Clinton, and big woman came to prepare. So it is converted into a stemming word, and then these words convert. Now these words are converted into a vector form. So how to do that? We use a one hot representation, or we can say that one hot library for we use here one hot. Okay, now we, in what we do in a one hot, Library, we need a word. So words we have a here we have a word, and then it is converted. It is a box size. Means here we define a box size is around 5,000, and then what is the our words? Words in corpus. Whatever it is present in a corpus is just sent to a word, and word is converting to a one hot uh, representation with the help of a box size we taken as around 5,000. Okay, so print one hot word is zero means that corpus is one, and corpus is zero. What is the corpus is zero? It is house can aid. So suppose that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and both are the same words. So these words are represented in the form of a vector, and here house is represented as a index value for 1075, and dam is the index value is around 2611, and these each word is represented with their index value here. Okay, and here, okay, and this is our corpus, and this corpus now it is converted into a one word coding representation. Okay, now what we do, now we convert into a padding sequence. Padding sequence, here it is means that all the sentence which is present in our data set are converted into a same length. So what we do, we first define the sentence length is equals to 20, and means that we convert all the sentences which is present in our data set uh, into a same length is equals to 20. So what we do? So we use a embedding technique equals to padding sequence, and one hot word, whatever the one hot word, here we have a one hot word, means that one hot word, and then it is passes with word padding means equals to free, means that padding equals to free means zero are placed first and then present their index value. Okay, and then maximum length is equal to sentence length. Okay, so it has a maximum length is 20, and uh, empty part of the sentence is replaced by zero uh, in first order. Okay, so this is a representation of our printing embedding. Okay, and length of embedding is same as our data set after the dropping the null value. Now what we do here, we just use is for our embedding layer, we use the embedded vector feature, and equals to 40, because embedding technique, in an embedding technique, we convert, we need a feature value. Feature uh, we use for the analysis of a relationship between the words. It is just like, okay, so here we define a 40 feature we have taken out in our for the analysis of a, for we can say that for the analysis of a sentiment of a word. So what we do, uh, we select the model is equal to sequential. We use a sequential model, and then we use embedding technique. What we use a walk size. It is equals to 5,000, and embedded vector feature we already convert into a 20 length, 20 sentence length, and put it length to 20 sentence length. Yeah, and here we use a LSTM model with single layer, and it has 100 neurons is present in a single layer. Okay, and then we use a dense and dense layer, and here is the output is 1. Acceleration is uses as a sigmoid, and for compilation we use a binary cross entropy, because our data sets, the output of our data set is presented to a 0 on our one format, so we use a loss function as a binary cross entropy. And here we use a optimizer as a atom. We also take a different type of uh, optimizers like a ReLU or softmax another, but Adam is a good optimizer, so we use Adam. And matrices we use accuracy, and then we just print the summary of our model. This is a embedding LSTM and then layers are presented in our data set. And then what we do, we just import the NumPy library and convert into whatever the embedding, we convert into a first array format, and y is also converted into NP array by the help of NP library, and we place as a x final shape dot y final shape. Okay, this is our embedding. Okay, so it is converted into a array format and then placed into a x final or a y final. Okay, now we train a model. For training and testing analysis, we divided the data set into zero point 0.3 test size, means that 70% data are used for training analysis and 30 is used for testing analysis, and random state is equal to 50 is used. Okay, and here we fit the model, extend and widen, and validation data is this X test and Y test, and epoch is 10, means that 10 time iteration, sorry, iteration is occur, and batch size is equals to 64. Okay, batch size means the sample size is like okay, so what we check, the accuracy is around 99%, so it is very good accuracy uh, with this data set. And performance matrices and accuracy also check. So what we do is we just y predictor model dot predictor x test value from x3. Okay, confusion matrix. Okay, and then confirm y test equals to y predict. Here it is what we predict and what is our output. So it is very good accuracy for this data set. And from trace normal accuracy score, accuracy y test is close to 90%. So it is very good accuracy. I believe that. So our output is good for this analysis. With the help of this, we find out the news in today's scenario, because in a today world, fake news is spread it everywhere for the for beguile the people or misconvey the people. So it is very uh, necessary for first we analyze the um, first we analyze the importance of a news. It is fake or true, and then it is passes to the other medium. So okay, this is my another project which I share with you, and thank you. If you like it, please subscribe my channel, also hit the button. Thank you.